can hear me, can you type something in the chat just to make sure? Let's try this.
Hello, can everybody hear me okay? Can you type something in the chat if you can hear me? Ah, okay, good, brilliant. Right, okay, so today we're going to talk about maths, about the harder problems in maths, so the differential equations. And if you are completely lost with a question, you can ask me in the chat. For example, if you'd like me to give you some tips on question number 8 or question number 9, just let me know in the chat. In this second half, I'll give you some hints as much as I can. Right, so let's start. So I'm going to share my screen. Okay, so the first question is an equation. We don't have many equations in the assignment, but this was a very interesting. This is a very interesting one. It is an equation with a parameter, and the question is, for which values of the parameter a does the equation have only one root? Okay, so we have two logarithmic functions, and they're equal to each other, and we need it to have only one root. Well, let's see. Let's see what we can do. Well, first of all, we can take the 2 and put it here, yeah, as a power. So we got logarithm of x plus 3 squared equals logarithm ax. Okay, so that's one thing. Another thing which we need to consider, that x here, x plus 3 must be positive, because you cannot take a logarithm of a negative number, and that means that x is greater than -3. And also ax has to be positive. Ax has to be positive. And that either means that a is positive and x is positive, or a is negative and x is negative. So when a is positive, x can only take positive values, and when a is negative, it can only take negative values. So from here, we already see that dealing with negatives is a bit of, well, it's quite tough in here. So let's consider the positives first. So first, suppose consider a is greater than 0. This makes our life much easier. So what do we have? Well, if a is 0, it's very easy. We have x plus 3 squared equals ax. We expand, x squared plus 6x plus 9 equals ax. Take this to the left-hand side, we get x squared plus 6 minus a x plus 9 equals 0. Just a second. Yeah, that should be fine. Just a second, guys. Sorry. Apologies. I think I might have made a mistake. This is awkward. No, the thing is that in the setting of this question, this would lead to a equals being equal to 0, which is not possible. Just give me a moment. Where have I gone wrong? One, 3, 8. Right, I might have lost it. Well, okay, let's solve it like this, as it is. So what's happening here? So we have it's a quadratic equation, and this quadratic equation must have one root, and we know that the quadratic equation has one root when the discriminant is 0. So discriminant is 6 minus a squared. Just double checking. 2 goes here. Plus 9. Okay. Discriminant is, if there's only one solution, the discriminant must be 0. Discriminant is b squared minus 4ac minus 4ac, so 4 times 8 times 1 times 9, which gives us 36 minus 12a plus a squared minus 36. And this has to equal to 0, because a quadratic equation has exactly one root when the discriminant is 0. So 36 cancels, and we've got a squared minus 12a equals 0. So that means a minus 12 equals 0. Now, so from here it means a equals 0 or a equals 12. But then there's a problem. A cannot be 0, because we saw that if a is 0, we take logarithm of 0, and this is not possible. So this is not a solution. So this is so we need to reject this one. And a equals 12 is a solution. I'll show you later. I'll show later to you that in fact it is a solution. However, what happens next? Well, what we need to understand is we need to consider negative a's. So if a is positive, for a equals 12, there's a one solution. So now to consider a is negative. Now here it's going to be very difficult to do it from analytically like this. So what I would like to do is actually just to sketch these two functions. Sketch these two functions and see if that gives us any insight on the number of solutions. Well, 2 logarithm x plus 3 has a domain from -3. So it's the logarithmic function shifted to the left by 3 and stretched out. We're not really interested in the y-intercept or x-intercept. We know that the graph looks like this. This is y equals 2 log x plus 3. Now, if we sketch the other one, logarithm ax, where a is negative. So a is negative, that means it is a reflection on the y-axis. So the logarithm it looks like this. If a is positive, and if a is negative, it looks like this. So if we sketch that, we immediately see that this graph, these two graphs, have exactly one point of intersection. And because this line is the asymptote, so x equals 0 is the asymptote, they will always have exactly one solution, no matter what a is. Is that making sense? Is that making sense? How much sense is it making, guys, on a scale of 0 to 10? Vote in the chat, please. Okay. All right. So as long as we understand the property of the function, the property of the logarithmic function, and we know that it's so this for negative a. For negative a's, this is something happened. It went blurry. I'll have to refresh. Apologies. So a little bit more strictly speaking, for the interval for x from -3 to 0, log ax. So if a is less than 0, okay, yes, it is a monotonically decreasing function. It's a decreasing function. And log x plus 3 is an increasing function. And you can see the range of these functions is from -infinity to a fixed value. From -infinity, so the range, if you look at the range, it's to a fixed value. It means these functions have to intersect. These functions intersect, and they have there will always be a point of intersection. Increasing function from -infinity to a fixed value, let's call it, I don't know, a, and from -infinity to a fixed value, let's call it b, and that means one point of intersection. And therefore the answer is a equals 12, or a is less than 0. And I promise to show you that, in fact, this is true. So Desmos is a fantastic tool when you're dealing with stuff like that. So y is equal to 2 log x plus 3. So you can see this function. And y is equal to log ax. And add a slider, and slider from -10 to 15. Let's make the step 1. Okay, so the blue function will change as I change a. So when a is 1, it's like that. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Sorry, 12. And as you can see, for 12, there is one point at which they meet. If it's more than 12, we have 2 points now. We have 1 and 2. For 15, you can see that now they have 2 points of intersection. And let's go the other way. So 15, 14, 12, again, 1 point. Now they are not touching. For a equals 11, they're not touching. So therefore, there's no points of intersection. And moving back, a equals 0, it does not exist. As you can see, Desmos tells you, no, sorry, not going to happen. But then for negative values, you can see that for any negative value, there will be a point of intersection on the interval between -3 and 0. Okay, so that is how you approach these questions like that. There will be more. There will be questions more like that. More questions like that in the next few assignments. So yeah, be prepared. Okay. Now, a differential equation. Differential equation. This is the next problem. This is one of the problems that didn't make it into the assignment, but it is very similar to the differential equations that you have. So a motorboat of mass 400 kilos is accelerating from rest. The engine provides a constant thrust of 800 newtons. The water resistance could be modeled by this equation. And so it's sort of a more physicsy problem. Well, it is mechanics. So you would, if you're doing further mechanics, you would see problems like that in year 13. So we have a boat, and there's a constant force of 800 newtons. And there's the water resistance force, which is acting backwards, which is kV. I don't need the minus because this is a vector. I can see that it is backwards. K is 40, okay, and V is the speed of the boat. So what happens is that as the speed of the boat increases, the water resistance increases, and at some point they become equal. So let's check when they become equal. The terminal velocity. Terminal velocity is when KV, so answering question A, KV is equal to 800, because these are the only two forces acting on the boat, and it's very simple. So K is 40 times V terminal is 800, and V terminal is 20 meters per second. 20 meters per second, very simple, 20 meters per second. Okay. The function Vt, i.e. how the velocity of the boat changes with time. And so this is the differential equation part of the question. So to answer part B, from Newton's second law, so Newton's second law, we write down that mass times acceleration is equal to the resultant force, and the resultant force is 800 minus kV. Okay. Can we use the values? Well, in physics, I would say definitely don't use the values for now, but in a math question, you can do it. So the boat is, actually, sorry, changed my mind. I'm not going to use the values. I'm going to use F for thrust and minus kV. Okay, so from here, I'm going to write down, because I know acceleration is dv dt, so mass dv dt is equal to, and here I'm going to do this, minus kV plus f. So I just changed them because I want a linear function in terms of v. So you can see that this is a linear function in terms of v. So it's like mx plus c. Now I multiply everything by dt and divide by m. So I got dv is equal to minus kv over m plus f over m dt. So this is a linear function in terms of v and times dt. So I divide everything by that. So why do I want that? Because I want to separate the variables. I want everything related to V on the left-hand side and everything not related to V on the right-hand side. But also, I'm only allowed to have two terms. If I were to add KV here, so this would move to the left, but then I would have three terms, and it's difficult to deal with three terms. Okay, so if you want a separation of variables, you have to have two terms. So you divide by that. So you get dv over minus kv over m plus f over m equals dt. Equals dt. I'm just going to make my life a little bit easier. So I'm going to take the 1 over m. I'm going to take it out. 1 over m. That doesn't change it. It doesn't really change anything. Just makes my life a tiny bit easier. 1 over m. So now I don't have to deal with this, with these fractions on the bottom. That's f. Okay. Any questions so far? Is there anything you don't understand? Can we get a quick vote? The usual 0 to 10. How well you understand, I mean, what I've done so far. Okay, oh, very good, very good. So from here, I could just input the parameters, and I think it's worth doing so. Yeah, I'm going to input the values. So k is 40. So I've got 1 over minus 40 v plus 800 dv equals 1 over m, which is 1 over 400, I believe. 1 over 400 dt. And now I can integrate. So what I do is I just do that. And I'm going to start from. So here you have a choice. You can integrate with limits or integrate without limits. I think I'll show you both. I'll show you both ways. So first, indefinite. Indefinite integral. Finite. So this is a integral of 1 over ax plus b. We know that this integral is logarithm ax plus b, x plus b plus c. I think it's 1 over a, right? 1 over a ln x plus b must be. Check. Yeah, that is correct. So we have the indefinite integral. So the integral of that is going to be 1 over minus 1 over 40 logarithm of minus 40v plus 800. Sorry, I'm just going to make a few steps. I have overcomplicated it, and I do apologize for that. So I'm going to just do a couple of steps back just to make this integral much simpler. So here, I'm going to take dv. Apologies. So dv is equal to dv over dt is going to be minus k over m v plus f f over m. So all I did is I divided by m. Then I will take minus k over m out of the brackets. So dv dt is equal to minus k over m v plus minus v minus f over k. Yeah, so if we expand, we get the same thing. And now we multiply by dt and divide by the bracket. So we get dv over v minus f over k equals minus km k over m dt. Right. So this is way easier. And I don't even need to bother with the numbers yet, because the integral is f over k, and this is minus k over m. And this integral is much easier to evaluate. This is going to be logarithm of v minus f over k. And here I have minus k over m t plus a constant. Now I have a choice. I have a choice of which constant to use. And I don't have to use c always. I can do logarithm c. So instead of the constant, I'm going to logarithm c. And you will see later why. Logarithm c instead of just c. So I'm going to rewrite this as an exponent in exponential form. So I will have v minus f over k. And of course, a very simple analysis will show you that this value is positive. So you can actually ignore the brackets. You can ignore the brackets. A second, 800 of. It's actually going to be always going to be negative. What's going on? Okay, I won't ignore the brackets yet. Okay, sorry. I won't ignore the brackets. The modulus e minus k over m t plus logarithm c. And I can rewrite this as e to the power minus k over m t multiplied by e to the power logarithm c. And I know that this is C. So it's going to be C multiplied by E minus K over M T. Okay. Yes. And now I need to analyze what's going on here. Empty. If I plug in the numbers, it's going to be much easier. So this expression inside the modulus is always going to be negative, because if you evaluate f over k is going to be 800 divided by k, which is 40, so it's 20. The speed of the boat can never exceed the terminal velocity, so this value is going to be negative. And the modulus of a negative value is the opposite of that value. So because v minus f over k is less than 0, we can write down minus v plus f over k equals c e minus k over m t. And now we find v is equal to v is f over k minus c e minus k over m t. And all right. Okay, so now we can plug in the values. So v of t, this is the function, f over k, that's 20, minus c multiplied by e to the power k over m, so it's minus 0.1 t. We need to find c now. To find c, so we know that when t is 0, c is when t is 0, v is 0. So v of 0 is equal to 20 minus c e minus 0. Well, it's 0, e to the power 0, and e to the power 0 is 1. So c is, and this has to be equal to 0. Therefore, c is 20. So the function becomes v of t is equal to 20 minus 20 e to the power minus 0.1 t. This is the function of v, and we can plot that. So let's have a look. V is equal to 20 minus 20 e to the power minus 0.1 t. Ah, very nice. Oh, of course, we need to limit t as positive. T is positive. And that looks very familiar. This looks very familiar. It looks very similar to the to a skydiver graph, for example. And so this, and you can see as time increases, the speed approaches 20. Usually, it is written in a slightly different fashion. V of t is equal to 20 1 minus e to the power minus 0.1t. Okay. This is using the indefinite integral. Using indefinite integral. So integral with no limits. Integral with no limits. You use the initial parameters to find c. Now, if you didn't do this, you would still have the same answer. You still have the same answer, just a slightly more difficult way to getting there, like ever so slightly. But let's have a look at if you prefer integrating with limits. If you prefer integrating with limits, you need to do the following. You need to, well, preferably you need to change the variables here. So instead of dt, I'm going to use d tau. Instead of dv, I'm going to use du. And here, u. So I'm just changing the variables, v for u. Why I'm doing that? Because the limits will contain v. So the speed changes from 0 to v, because v is the final speed, is the speed at time t. And similarly, the time changes from 0 to t. And that's what we can do here. So we integrate, we got logarithm of v minus f of O on k minus logarithm of 0 minus f on k equals minus k over m t. I hope I don't need to explain why this is minus k over mt, is because you plug in t and then minus 0, so you're left with this t. And here, so you get this. When we remember that this is a, well, I'm going to use the values v minus 20 minus logarithm of minus 20, but it's modulus of minus 20, so it's logarithm 20. Logarithm, I don't really need. Okay, logarithm of minus 20 equals minus k over m, which is 0.1 t. So logarithm of, now I'm going to round brackets. So v minus 20 is negative, so I have to take I have to take 20 minus v minus logarithm of 20 equals minus 0.1 t from, so I put the two logarithms together. I get logarithm of 20 minus v over 20 is equal to minus 0.1 t. So 20 minus v over 20 equals e to the power minus 0.1 t. Then I get 20 minus v is equal to 20 e to the power minus 0.1 t. V, well, which is v of t, of course, is a function, is 20 minus 20 e minus 0.1 t. which is 20. 1 minus e minus 0.1 t. Okay, so I got the same answer, just two different approaches. One using without limits and using integral with limits. Integration with limits. Okay, any questions? Any questions? That's a good one. Well, this is a philosophical question between practical and impractical. If you put a glass of hot water in a room, the initial temperature is 100 degrees. Yes, if it's very hot, boiling hot water, you pour a glass of water, it's 100 degrees, you put it on a table, the room temperature is 20. What's the final temperature of the water? Well, everybody knows the final temperature of the water is going to be room temperature. But is it? If you write down the equation, you will see that it's just like the boat, it will never actually reach 20 degrees. So in physics, as long as the difference is unmeasurable, there's no difference. Okay, when you do capacitors, for example, you say that after five time constants, we deem the capacitor as fully discharged, even though it never actually fully discharges. Well, I mean, only when the charge is less than 1 electron, something like that, when all the electrons have left. But if you look at the graph, yeah, of course, it will never be 20. But let's say after 60 seconds, the speed is going to be 19.95. Is it practical to say that it's 19.95, or is it more practical to say it's 20? Because no machine will be able to measure that. And this is taking ideal conditions. A boat in perfect conditions, no wind, no shaking water or anything like that. So I don't really know how to answer the question. As long as the difference is, you can say that the boat is traveling at a constant speed once the accelerometer in your boat shows 0 acceleration and the speed shows 20, because it cannot tell the difference between 19.95 and 20. So we're using a model, we're using an approximation. In reality, the situation would be slightly different. So it would be, if we take this graph and just draw it here, a real boat on real water, there would be much more noise. So most likely the speed will fluctuate around the terminal velocity. So in practical terms, terminal velocity is impossible. The speed will always change a little bit because of the changing air resistance or the changing wind or the changing water waves on the surface. You can never see a boat traveling at exactly constant velocity. It's impossible. So we're using an approximation, which is a very good approximation. Right. I hope that explains it roughly. James, does that make more sense, James? Okay. Okay, so the speed of the boat after 1 second, 10 seconds, and 100 seconds. Well, all you need is just to plug in the values here and here. And well, you can see after 1 second, I'm just going to use the graph. After 1 second, the speed is going to be 1.9. So 1.9 meters per second, 1.9 meters per second. After 10 seconds, it's going to be 12.6 meters per second. And after 100 seconds, it's going to be 19.999 meters per second. So after 100 seconds, it will reach terminal velocity. Well, it will reach terminal velocity after about 60 seconds. Yeah, it would be impractical to say it will never reach terminal velocity. Okay, the other problems are simpler, so don't worry. And this one is a very nice one. Has anyone attempted it? Has anyone managed to solve it? It would be great if you I know I give you a little time before the start, but I am working on improving that to posting the questions a couple of days early. It's just now I'm very busy with the next assignment. Okay, so you have this. Well, one of the properties of the logarithm is you can write down that logarithm of a b is log c b divided by log ca. This is known as the change of base formula, which is, and this comes useful here. So logarithm of 2 over n can be written as log n over logarithm n2. Or in other words, it can be written as 1 over logarithm n2. And actually, no, change the base to n. So we're changing the base to n here. And as you can see that this turns into that. But because it's already flipped, it's already the reciprocal, we can write that 1 over log 2n can be written as log 2 base n. And yeah, so let's write this. So this is going to be n to the power log n, or log 2 base n, multiplied by n log 4 base n. Oh, okay. So times etc. and up to n log 512 base n to the power of 1/15. Okay. All right, I need to tidy this up a little. Okay, so here I can write, but we know that a to the power log a b is b. This is the main logarithmic identity. So n to the power log 2 base n is going to be 2. So the main expression here is going to be 2 multiplied by 4 multiplied by etc. multiplied by 512 to the power 1/15. Of course, you can do it on a calculator because these are powers of 2, and there's only nine numbers, and most calculators are happy to do that. I mean, if you use a financial calculator, it will probably stop working at some point because the numbers are too big. But I'm going to do it differently. I'm going to say 2 to the power 1 multiplied by 2 to the power 2 multiplied by 2 to the power 3 times etc. times 2 to the power 9 and to the power 1/15. So which is going to be 2 to the power 1 plus 2 plus 3 plus 9, 1/15. And then we remember the formula for the sum of the first n integers. So 1 plus 2 plus 3 plus etc. plus n is going to be n plus 1 over 2. You can this is the formula for triangular numbers. It's a very useful formula, but you can also use the sum of an arithmetic. It's an arithmetic series. Yeah, and you can prove that formula using the arithmetic series. But this pops up a lot, so I recommend you remembering that. It comes in useful. And so the sum of the first 9 integers, 1 plus 2 plus 3 plus 9. I'm using a complicated formula as if it's not, as if it is not super easy to just add 1 plus 2 plus 3 plus 3. But I'm that lazy. I will not go for 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 because I'm too lazy. I'm going to use that formula. So I'm going to be 9 times 10 over 2, which is 45. Okay. So it's going to be 2 to the power 45 to the power 1/15, which is 2 to the power 3, which is 8. Full stop. Okay, so but of course you understand why I'm doing that, because if I were to do 1 to 90, I would have to use that formula. Problem 4. Any questions on problem 3? Any questions here? I think it's very self-explanatory. The most difficult thing is just to see what to do. Yeah, because somebody suggested to change the base to 2. Actually, that could work. I'm sure you could do that, and you would probably get you would get to the same result, just in a slightly more complicated way. We had a similar question to that. It might not be very clear, but there was a question in the assignment. There was a question in the assignment. Where is it? One of the questions. Yeah, so if x is this, y is this, find x and y. Okay, so it's not exactly the same, but the idea is the same. You have two expressions, you need to find x and y. Basically, it's simultaneous equations. Yeah, so and here what we can do, we can see that the bases are different, so that hints us that we need to use change of base. But before we start, we need the range for x and y. Basically, which values of x and y are allowed. So here we can see immediately that x has to be positive, because you can't take a logarithm of a negative number. Y has to be positive, because you can't take a logarithm of a negative number the same way. Now the base of the logarithm has to be positive. Well, that's already written here. But also it cannot be 1. The base of the logarithm cannot be 1. So x is not equal to 1 and y is not equal to 1. My advice to you, whenever you do a task, start with this. Yes, start with this, with the possible values for x and y, because that will make you don't have to do it for easy questions, but for harder questions, it makes life easier. Okay, so change of base. It doesn't really matter which base you choose. You will arrive to the same answer. Whichever base you like best, you can do. I prefer the I'll do the natural log. Okay, change of base to the natural log. So it's going to be ln x divided by ln y plus ln y over ln x. Apologies. Equals to 2. So I'm just going to deal with the first one. The second one is very straightforward, so it doesn't really matter what you do there. Okay, so here I'm going to multiply by ln x and ln y. And there won't be no problem of losing the denominator, because x is not 1 and y is not 1. So the denominator is not 0. So I can multiply it. So it's going to be ln squared x. Okay, not a very good notation. Ln x squared plus ln y squared. I'm finding the common denominator. Ln x ln y equals to 2. Multiply everything by ln x ln y. So ln x squared plus ln y squared equals 2 ln x ln y. And then it's like, wow, that's kind of tough. Like, what do you do with that? Well, let's take this to the left-hand side. Ln x squared. minus 2 ln x ln y plus ln y. So what gave me this idea? Because I mean, it's not the most obvious thing to do, to take this to the left-hand side and put it in the middle. In my head, what was going on in my head when I first approached for problem 12. Problem 12. Radians. Yeah, radians. For problem 12, it's definitely radians. I'll put if you can put that in the chat, Aidan, into the main chat, just say, yeah, problem 12 is solved in radians, if anyone else is wondering. So so what gave me this idea? Well, in my head, I did the following. I said, let's do a substitution. Let's make A equals ln x and B is equal to ln y. And what I have essentially is a squared plus b squared equals 2ab. And this looks very comfortably familiar, because if you do a squared minus 2ab plus b squared, you get a complete square. You get a complete square, and this is the stuff that was going on in my head when I first looked at this problem. Yeah, when I was first doing it. So I can see this structure here now. So it's going to be ln x minus ln y squared is equal to 0. Well, this obviously means one thing. So only 0 squared is 0. So the expression ln y is 0. So ln x equals ln y. And ln x equals ln y can only mean one thing, that x is equal to y. I think I've spoken about this before, but logarithm is a monotonic function. Logarithm is a monotonic function, and it is a one-to-one function. So if logarithm x is equal to logarithm y, that can only mean that x is equal to y. So for example, if we had sine x equals sine y, x does not mean that x is y. Yeah, or it also doesn't mean it's not equal to. So this does not mean that. However, this means that, because logarithm is a one-to-one function. A monotonic is a one-to-one function. Why we call it monotonic? Sorry, every monotonic function is a one-to-one function, but not every one-to-one function is a monotonic function. I'll clarify. So a monotonic function is that is constantly decreasing or increasing. So for example, this is a strictly monotonic function. Yeah, it's always increasing. Increasing means that if x2 is greater than x1, that means f of x2 is greater than f of x1. A very important concept in maths. And one of the assignments will be on functions. So that's that. So x and y. This, yes, a monotonic is a constantly increasing or decreasing function. So a one-to-one function does not have to be monotonic. especially if it's a piecewise function and the pieces are not connected. So it could be a, yeah. Anyways. So x is equal to y. And that makes, and this means that we can solve, we can substitute that into the second equation. So from the second equation, we get, sorry, it's x squared minus y equals 20. X squared minus y equals 20. So x squared minus x equals 20. X squared minus x minus 20 equals 0. So x is 5, x is minus 4. I'm using the Vieta's formulas here. So they multiply to negative 20, they add to 1. Add to 1, multiply to negative 20, so x is 5, x is 4. But this is where, well, this is why I told you that this is very important. Yeah, x has to be positive. So we have to reject the negative. We need to reject the negative value. Reject. So x equals 5. Equals 5, and of course y is also 5. And that's it. That's the solution. Okay. So for problem 5, I wanted to talk about this. I'm not going to go through. I'm not going to go through the problem 16 from the assignment. I just want to do another problem which is loosely related to it, just to give you an understanding of what kind of concepts we're dealing here. So let's look at problem 16 first. A kettle containing water with a total heat capacity of 5,000 is cooling down from an initial temperature of 100 degrees. The rate at which heat is dissipated is proportional to the difference in the kettle temperature. So this is the formula, which can be written as that. So I just want to clarify a little, like, how do we get from here to here? Well, you have a kettle. You have a kettle with water. And just like a kettle can hold, I don't know, one liter of water, it can hold so many joules of energy until it starts boiling. So heat capacity of 5,000 joules per Kelvin. This 2 is a footnote. It's not a square. I hope that's clear. It's blue too. So 5,000 joules per Kelvin. It is by all means. Newton's law of cooling. And so you have C equals 5,000 joules per Kelvin. That means to take the water from 100 to 20, you need 80, which is the difference in temperature. Okay, it's going to be 100 minus 20 multiplied by 5,000. 5,000. This is the amount of heat that needs to be dissipated in order for it to reach room temperature. Okay, now if we have boiling water at a temperature T, for example, and we lose some heat, the amount of heat is dq. We need to know by how much the temperature drops. The temperature drops by dt. Okay, so dt, well, we know the formula for the heat capacity. So the Q is CT. Well, actually, delta Q is C delta T. Now, in physics, you have this. You have delta Q is equal Cm delta T. But this is specific heat capacity, and this is heat capacity. This is the total heat capacity, not per kilogram, but per kettle. So that means the formula is slightly different. It's capital C delta T. So these formulas, this is specific heat capacity, and this is total, or just heat capacity, not specific capacity. So different kettles will have different heat capacity. Right, so this is the total energy required to cool down. Yeah. K is Kelvin, absolutely, but it's not squared. This is a footnote. I know it's confusing. I just realized that it might be confusing here. Look, if you zoom in, you will see that the 2 is blue, and blue is a footnote here. The 2 means a footnote. So the 2 is not a square. That is, yeah. MC delta T. So that means that for small changes, dq is equal to C dt. But there's a catch here. dq is the amount of heat released into the room. So the amount of heat that is lost by the kettle is going to be negative because the kettle is losing energy. That's why we say dq is going to be equal to minus C dt. And that is why we can from here we can write minus C dt, d capital T divided by dt equals R T minus R, TR. And then from here, it's the absolutely same thing what I did with the boat. Okay, so it's the same thing. You already have the equation, so all you need is to integrate it and put the limits, put the proper limits. So you need to rearrange that, range and integrate. You need all the capital T's on the left-hand side, on all the small t's on the right-hand side. Well, there's only one small t. Rearrange and integrate. So that's for this question. To get your this is an Olympiad question, which is loosely related to the kettle question. And the first time I read it, I was baffled. Like, how on earth can you do anything here? The radiator in a room is kept at a constant temperature. When it's -10 outside, it's +20 inside. When it's -30 outside, it is +10 inside. Find the temperature of the radiator. It's like, to me, it sounded like two boys walk to school at one with a speed of 3 meters per second, one with a speed of 2 meters per second. What is the name of the first boy's dog? Yes, it's completely unrelated. It sounded to me just like that. Like, how on earth is it possible? And this is a physics question, so sorry to intersperse our math evening with physics, but well, first thing, let's do a drawing, because any physics question starts with a drawing. And you have a room, and inside the room you have a radiator. You also have windows and doors and walls. But let's, for simplicity, say that the walls are absolutely perfect and you only lose heat through the window. So the radiator is at a temperature T. And when it's -10 outside, -10 degrees Celsius outside, you can understand where this question is coming from. It's where the climate is quite cool, perhaps Canada. And this is, the room is +20. And when the temperature outside is -30 degrees, the temperature in the room is +10 degrees Celsius. And the radiator is at the same temperature. So that's what we need to find. So we need to understand that the radiator is giving energy to the room at a rate dq dt. But the room, sorry, dq dt, all right. I'm just going to put Q with respect to T. Qt is the radiator is giving you heat, but then you're losing that heat through the window, and of course through the walls and everything, and the insulation, and you're constantly losing heat. But the important thing is that you are losing the same amount of heat, because if the room is at a constant temperature, that means you are getting heat from the radiator and losing heat from the radiator at the same rate. Because if you were receiving more, yes, of course, we are talking about thermal equilibrium. When I say the temperature in the room is 20, that means the thermal equilibrium temperature. So that means you are receiving the same amount of heat as you're losing. And that's why the temperature is constant. And we know that the rate at which energy is dissipated is proportional to the difference in temperatures. This is Newton's law of cooling. We know that the Qt, or Qt is dq dt, is the derivative dq dt, is equal to a coefficient multiplied by the temperature difference, T2 minus T1. Okay, so for the radiator, let's say that there's a coefficient alpha for the radiator, alpha 1, or yeah, alpha, and for the window it's going to be beta. So in the first case scenario, we have the heat supplied to the room is alpha multiplied by T of the room minus the temperature of the radiator, which is T. And the rate at which the window loses energy is beta multiplied by T of the room minus temperature of the outside. Sorry, here, of course, it's going to be temperature of the radiator minus temperature of the room. Temperature of the room and temperature out. And because the amount of heat per second you receive from the radiator has to be the same as the amount of heat that you lose through the window, has to be the same. So we can write that alpha multiplied by T minus temperature of the room, which is 20, it has to be equal to beta multiplied by temperature of the room, which is 20, and minus the temperature outside, minus 10. Or alpha T minus 20 equals 20 minus 10 is 30b, 30 beta. Okay, that's the first equation that we have. Now we do the same equation when for the other temperature. So when alpha T minus 10 is equal to beta 10 minus 30. So alpha T minus 20, T minus 10 equals 40b, 40 beta. Again, that's the second equation. Now it seems like we have two equations and three unknowns, and it will be tough to do. But actually it's not two equations and two unknowns. If we divide the first equation by the second one, we get T minus 20 divided by T minus 10 equals 30 over 40. And solving that, so 10, this cancels by 10, so we get 40 minus 80 equals 3t minus 30. T is equal to 50 degrees Celsius. Okay. So did you enjoy this question? I hope you're fascinated by it. So it's just, I just find it so elegant that you go from a very difficult concept with very little input data, and actually you can solve it. So why was I saying that this is three unknowns and two equations, and you can still solve it? Well, because alpha, and if you divide both equations by beta, you get alpha over beta. So it's actually two unknowns. One of them is t, and the other one is alpha over beta. Is a ratio. You have the constant rate. The alpha and beta, we say they are constrained. They have they're interlinked. So they are dependent. That's why you can't. It's not really two unknowns if you know that one is 2 times the other one, right? It's one unknown. So fundamentally nothing's broken here. Okay, a very quick one. Problem 6. Find log 56 in terms of alpha a and b. Sorry. So log 56 can be written as log 7 plus log 8, which can be written as log 7 plus 3 log 2. Yeah, I'm using the property that 8 is 2 cubed and 3 comes out here. Okay, we know log 2. We don't know log 7. So we know that, but we don't know that. Well, log 7, let's change the base to 2. It's going to be log 2 . Well, that's not very useful. No, sorry. I'm going to do it the other way around. I'm going to take log 2, 7, and I'm going to change the base to 10. So it's going to be log 7 divided by log 2. And I know that this is b, and I know log 7, but I also know that log 2 is a. Therefore, I can say that log 7 is ab. So it's going to be ab plus 3a, and you can simplify this as a b plus 3. Why is this a simplification? Well, because it's only 2 terms. Sorry, one term. This is technically 1 term, whereas this is 2 terms. So I think it's more simple. Also, fewer symbols. Okay, so that's that. Sorry, it took me an hour and a half to do the whole thing, but I promised you to give you some tips if you are super confused with the question. So please please ask me if you with any particular question from the assignment. If not, then I wish you all the best. And how do you do question 6? Question 6. Oh. Well, question 6. Okay, let's copy that. Well, of course, you can feel free to just check your answer with the calculator, but it's not a valid explanation of why this is so. So let's try let's compare 2 numbers. Compare, I don't know, log 3, log 7 base 3, and log I don't know, 17 base 5. Is it good enough? Yeah. So both answers are somewhere between 1 and 2. Okay, so both are between 1 and 2. And you could use trial and error to estimate the values. So for example, you could find this value correct to 1 decimal point. So you could say, let's say log oh no, you wouldn't be able to do it without a calculator. No, sorry. Okay. So how would you do that? Well, you can say that okay. Could you make the bases the same? Yes, you could make the bases the same. So, I mean, this is slightly different, but what you need to do is you need to do this following. Suppose log 3.7 is greater than log 5.17. I'm going to suppose that. If I am wrong, I would come to the wrong conclusion. Then we can say that log 3.7 minus log 5.17 is going to be greater than 0. This must be true, and is greater than 0. Okay, so log 7 divided by log 3 minus log 17 divided by log 5 is greater than 0. Then you multiply them. Log 3 and log 5 are both positive. So we can multiply. So it's going to be log 5 multiplied by log 7 minus log 3 log 17 has to be greater than 0. Greater than 0, so I'm kind of getting rid of the bottom log. So I'm multiplying by log 3 and log 5. So I've got this. And you carry on until you get something that is true. So let's say this leads to log 7 greater than log 12. You probably won't get that from here, but I'm just showing you the idea. Which is false, yeah? Which is false. Therefore, our initial assumption was faulty. So assumption. And then we can say false. Assumption is false. False. So the opposite is true. Yeah. So that's how you do. There's no last step. Sorry, this is completely made up last step. Because I'm just taking random numbers, and if you look at the question, the numbers are not random. You see, they are all multiples of 5, and that will help you. I'm not using multiples of 5 here, so it's a big question mark. Is that Is that making sense? I'm just showing you the method. Raise 10 to the power of that. 10 to the power of that. It could work potentially, but yeah, I don't see it. This is completely made up. Yeah, so I'm not. Made up question with a made up solution. Yeah, so I mean, you could do this, for example, compare cube root of 17 and what cube root of 17 is somewhere between 2 and 3, yeah, and square root of 7. Okay, so I assume that cube root of 17 is greater than root 7. This is my assumption, and then I just take everything to the 6th power. So they're both greater than 1. So I can safely take them to the 6th power. So I'm going to have 17 squared. So raising it to the power of 6 is greater than 7 cubed. 17 squared is 289, and 7 cubed is 243. 243, which is true. That means initial assumption correct. Initial assumption correct. This is how you compare two numbers. So you need to use this method. So if my initial assumption was wrong, I would get a contradiction. But because I got a true statement, that means my initial, in fact, that this is correct. It is more almost like proof by contradiction. Okay, right. So okay, good luck. The assignments are due this Sunday. Remember, 6th of March, and yes, see you next week. Okay.